Actually, Sid, do you want to start a little earlier? Because we might have two more.
Yeah, sure.
Okay. Yeah. Okay. So I'm gonna screen share the whiteboard here. All right. Cool. All right. So I'll be walking through this geometry problem, and Sid will be walking through the second problem, which is an algebra problem. All right. So I'm gonna read the problem again one more time. The coordinates of triangle ABC are A 5, 7, B 11, 7, and C 3y with y greater than 7. The area of triangle ABC is 12. What is the value of y? And then uh, the test makers are very nice to give you the actual triangle so you can visualize what's going on in the problem. And then we have 5 answer choices, 8 to 12. So to approach this, um, I think, well, obviously for every problem, there are a couple ways to approach this. But usually in a geometry problem, we want to make note of the constraints that are given to us. For instance, usually when they give you that the fact that the area of a triangle ABC is 12, um, usually an experienced contestant will think of the various area formulas that exist. For example, just to give an example, the well-known one half area is one half times the base times the height, um, or a half BH. That is just one of the area formulas. Another formula that could be R times S, which we'll cover in future lessons. But basically, the main idea is that when you're given this condition, the area, like especially if you're given one variable and then an area, uh, you you should have the sense that you're about to use some sort of formula to solve for what is given. Um, in any case, it's very important. It's also very important to circle what is given here. What you want to find, which is the value of y. So you may ask, like, what area formula should I use? Because you're obviously given the value of the area, which is 12, but like in all the formulas, there are different values, or there are different variables that you may or may not know the value of. For example, you may or may not know b, you may or may not know h, and you're solving for y. So how do you know which one to use? That usually comes with practice. So um, in in our example here, uh, we have three coordinates, and um, usually with three coordinates, there are a few ways to approach this. But does anyone have an idea of what the first step might be? Basically, the first when you're trying to set up, we usually want to set up an equation to solve for y. So does anyone have an idea where we might start with this? Oh yes, I'm gonna try to unmute. Oh yeah. So can you unmute this guy? Oh
Yeah.
yeah, you can. If you raise your hand, you can speak up, or just type it in the chat. Either is fine. Yes. Alan, there are, yes, that is very good. Um, yeah, for any like MCA, there are usually a lot of ways to approach it. I would love to hear it, how you did it. Uh, if you can like write it in the chat. So basically, like what I mean by an equation is that we're solving for a variable y right here. We can we can incorporate this value into one of our area formulas right here. So let's actually try one of our simplest area formulas, which is precisely one half times the base times the height. Um, so obviously, we can set it equal to 12. I'll use green again. Obviously, we can set it equal to 12 because we know from the given problem statement that the area is 12. But we don't know the base and the area, the base and the height. So um, we need to choose one of our sides of the triangle to be the base. And we also need to choose the perpendicular height from the opposite unincluded vertex from the base. So does anyone have an idea of what probably the easiest base to choose might be? Yes, that's the right idea. Um, so to elaborate, we can because the x coordinates of A and B are different, but the y coordinates are the same. We know that the length of AB is this x coordinate, 11 minus uh, the x coordinate of A. So it's just the difference of the x coordinates because they have the same y coordinate. They are basically on the same level, same horizontal level. So the length of AB is 6, and this will be our base. So let's write the base as B. Now we know what the base is, as Alan mentioned. We can draw a height, the h. We already know b, the base. So now we can draw the height h. The height must be from c, and we draw a perpendicular from c to the base ab. Why do we not draw a line like this or a line like this? Well, the height is defined as the distance from the opposite unincluded point. So in our base we're including A and B, but we're not included C. So the height from C all the way down to line AB. So if you extend AB all the way down here, if you just draw a line through AB, we know that the y coordinate must be 7. So if you like pick a point here, it might be like 14, 7. Or if you pick a point here, it might be something 7. So we know that this x coordinate, no, this point is 3 comma 7. Precisely because when we drop a line down such that it is perpendicular to a horizontal line, um, we know that these 2 points have the same x coordinate, and this point must be on, again, this whole line is has points that have a y coordinate of 7. So combining that, we have 3, 7. And now we can finish off the problem. The height h will be just the difference between the y coordinates of these 2 points, because they must have the same x coordinates. It's kind of like the same logic as we did with A and B, right? With A and B, we have the same y coordinates, so we take the difference of the x coordinates. And then for these 2 points, C and this newly formed point right over here, since they have the same x coordinates, we just take the difference of the y. So that would be the top minus the bottom. Also, we're given y is greater than 7. So this also gives us that like y can't be below y can't be below 7, which won't give us any negative answers. So this will be y minus 7. So now we can actually plug in h and b into our formula. So when we do so, we get 12 equals 1/2 times the base, which we found is 6, and the height, which is y minus 7, as we found right over here. And then now we can solve for y. So multiplying by 2 on both sides, we have 24. And then the half gets canceled out, so which is 6 times y minus 7. Let me move this down a little. We divide by 6 on both sides to get 4 equals y minus 7. And adding 7 to both sides, we get y equals 7. There we go. Oh, sorry, 11. 4 plus 7 is 11. So answer is D. Obviously, there are a couple of ways to approach this. Yes. Yeah. We basically, as Alan mentioned, we can say that A and B are 6 apart, precisely because the y coordinates are the same. So we can just take the difference between the x coordinates to find the distance between the 2 points, A and B, which gives us the length of the base. Yep. Sid, you can share your screen now.
You can just carry on with the same screen.
Or okay,
I need to.
it might be a little hard for
rejoin
you to scroll. No, that was what I was thinking. But yeah,
Yeah.
so we'll walk
Okay.
through this next one.
Yeah. So I'll be walking you through this problem. So all the marbles in Maria's collection are red, green, or blue, and then Maria has half as many red marbles as green marbles and twice as many blue marbles as green marbles. So what's the total number of marbles in Maria's collection? So in this type of problems, I always like to assign variables. And so, does anyone have any idea of like what the best type of designation for the value of x should be in this problem? Like, what's the best type of amount that we should label as x? There's 3 types of amounts, right? There's the number of red, there's the number of green, and there's the number of blue. So, what's the best type of amount? What's 4? Oh, so what's the best type of amount that like we can designate the value of x? So there's the number of red, blue, and green marbles. Yeah. So as Alan said, it's green, and many of you will see why in a sec. So I'll say so the number of green marbles.
Here's what I found.
Oh, my bad. Number of green marbles will be x, right? So that's the number of green marbles. So similarly, what's the number of blue marbles that Maria has? So what's the number of blue marbles that Maria has in terms of x?
Know that we don't know any like numerical
Yeah,
values.
we don't know any numerical values.
So just in
We just
terms
want
in
just in
terms of
terms of x.
number
Yeah,
of green marbles.
yeah, 2x.
Yes.
So, because the problem statement clearly says that Maria has half as many red marbles as green marbles, but she has twice as many blue marbles as green marbles. So if she has x green marbles, then she has oh, but she has 2x amount of blue marbles, right? And so what's the number of red marbles she has? Yeah. So if she has half the amount of red marbles as green marbles, then that's the least amount of or that's the amount of marbles that Maria has that are red in terms of x. And so it says that the total number of marbles is what we need to find. So which of these options could be the total number of marbles, right? So by the way, I think that's a bit hard to see, so I'll just erase some things. Yeah. So um so in order to find the total number of marbles, what can we do to each of our individual marble sizes? Because it says we need to find the total number of marbles. So what can we do to each? Yeah,
Yes.
yeah.
Add all
Yeah. So
amounts.
if you have to find the total number of marbles, you just add the individual. So we can add x plus 2x plus half x, right? And so what does that give you?
In terms of x, we don't know
Yeah,
any.
yeah, yeah. 7 over 2x. That's correct. Because if you add x and 2x, you get 3x, and then 3x and 3x plus half x gives you 7 over 2x.
You can
And
also
now,
write it as
and now,
three and one half x
yeah,
made.
yeah. But in as you'll see in this problem, it's better to write it like that, and you'll see why in a sec. So here's where I think is the most interesting part of this problem. So you'll realize that you don't need to actually do anything else other than look at the answer choices of this problem at this point, right? So 7 over 2x. So we know that the fraction has to be. So if we say that the total number of marbles will be some amount y, right? So let's say the total number of marbles is some amount y. Okay. Um, in terms of the way, so remember that the x is the number of green marbles, right? So the number of green marbles, the number of green marbles that you can get with respect to the total number of marbles is 2/7 of the total number of marbles. So you have a bunch of marbles, and then if you take 2/7 of that, you get the number of green marbles. And I hope it's clear how we got to that point, right? And so now you'll see that the number of marbles can never be a fraction, because the marbles are an individual entity, right? It can never be fractions. Like it would be like ridiculous to say that you could have half a marble or like 2/3 of a marble. Like what does that mean, right? So you have either one marble, two marbles, three marbles, and so on. So what we see from this statement right here is that the number of total number of marbles, which is y here, that has to be divisible by 7, because if that's not divisible by 7, then the number of green marbles will be some fraction. So if say the total number of marbles is 13, right? For example, I'm just giving you a random example. 2/7 times 13, and you'll get 26 over 7 green marbles, which is ridiculous, right? because there can never be a fraction of a green marble. So going up back to the answer choices, um, and then you scroll up to the answer choices.
Yes.
Yeah. So looking here, we see 24. Can 24 be a possible number, a total number of marbles? Yeah. 24 can't be one of the answer choices because 24 is not divisible by 7. We need it to be divisible by 7, the total number of marbles, right? Is 25 so as well? Yeah. No. So you can actually cross out all these options because 25 is not divisible by 7, 26 is not either, and so is 27. So the only answer choice we're left is E,
Yes.
and as we can see, that is divisible by 7, and going back to the equation about x equals 2 sevenths y, if we say that y equals 28, because y was the total number of marbles, so if the total number of marbles is 28, we see that the number of green marbles um, is going to be 8, right? And so if there's 8 green marbles, there's going to be 4 blue marbles, right? Because or 4 red marbles, because the number of red marbles is one half the number of green marbles. So there's 4 green, 4 red marbles, and then we see that the number of blue marbles is double that of green. It's going to be 16. And just to make sure that you've done this problem right, let's add up the individual marbles because then we'll get the total marble. So we can add up 8 and 16 and 4. And as you can verify, this gives you 28. So our answer here is 28 marbles.
Nice. Yeah. Okay. So to summarize, these two problems, what can we take away here? These two problems are on the AMC8 more like relatively simple compared to what you would see like usually in the last 10, I believe. Um, Note that all we did in the first problem was to apply one of our very basic problems, which you probably have learned in school, 1/2 times the base times the height. Uh, but but we used it in an insightful way. Like we had to choose like the appropriate base as well as the appropriate corresponding height, and so that we can solve for y. Um, and in the second problem, we expressed an unknown quantity in terms of a variable, and then um, as Sid found, and also you guys found, we got that the total number of marbles is 7/2 times, and the total number of marbles is seven
It's
half
7 times the
seven
7 over
seven.
2
Yeah.
times the number of green marbles. And
Uh-huh.
so,
Yeah.
um, so if the total number of marbles is 7 over 2 times the number of green marbles, if you say that the total number of marbles is y, which
Mhm.
is another variable, right? Um, then you can express the number of green marbles as 2 sevens of the total number of marbles, right? Because the total
Mhm.
number of marbles is y and the green marbles is x. And then by doing this, we can see that the total number of marbles has to be divisible by 7. Because if it's not, um, you're gonna get a fractional amount of green marbles. And a fractional amount of green marbles doesn't make sense in this case because obviously half a marble is not really. You don't really say half a marble. Like how can you get half a marble, right?
Mhm.
And so then you can go through all the answer choices, and the test and the problem makers have placed it in such a way such that there is only one value that's actually divisible by 7, which is
Yes.
E28. And
Mhm.
so as a form of verification, you can you can solve for the individual values of the number of green marbles, red blue marbles, and red marbles, as we did here. So we have eight green marbles, 16 blue marbles, and 4 red marbles. And then you can add them up and see if they add up to 28, which in this case it does. So that's just a useful way of checking if your answer is correct or not.
Hmm. Yeah. Okay. I don't think there is enough time to go through the other two problems.
Yeah.
And unfortunately, Google Meet has a 1 hour meeting limit. So I'm gonna post the two remaining problems on our website. So you can
Mm-hmm.
check us out on mathmagiclab.com
Yeah.
here.
And the YouTube is linked at the top, so you can check out the recording of this
Yeah,
session on
the
our
YouTube
YouTube
is
channel
linked right
as
over
well.
here. Yes,
Yeah.
we'll be posting the remaining two problems on these, and the link is mathmagiclab.com.
Yeah. Yeah. So the link is posted on the chat.
Yeah. Okay. Unfortunately, I think Google Meet is about to
To end.
kick us
Yeah.
out. But okay, so thank you very much for attending. Hope you
Yeah.
learned something new from it from
And we
our
hope to see you next time.
session. Hope to see you next time, and we'll be
Yeah.
sending a recap of 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 our materials
Mm-hmm.
through an email. Yeah. So thank you very much, and see you next session.
See you next session. Bye.
Bye.